In Chapter 2, we began our introduction to SAS with the data step. We learned the data input data line sequence of statements for creating a data set in SAS. In Chapter 3, we learned a couple new procedures, which were the proc univariate and proc means procedures. In addition to that proc print we did also saw in Chapter 2. But the idea was we introduce how to create a data set, we introduce a few procedures on how we can manipulate that data set, even if it's as simple as printing it, or if we want to do some sort of a data calculation. So as we move forward in the book, what happens is we'll revisit a data step or how we can create a data set, and we go back to the data step and learn how it can be modified. That's the objective of Chapter 4. Okay, so what we want to create then are new variables in an existing data set, or as we create the data set, we keep the columns indicated in the input statement as minimal, but perhaps we're looking at some transformation of those columns. So we look at new variable assignments and data transformations within a data step operation. So we're going to modify then that data input data lines sequence of steps, and we're going to insert some new lines to create new variables. In Chapter 4, we introduce a fish data set. The objective here then is that the data, we just simply call it fish. There's an ID for some fish that were caught in the location pane. We have a length expressed here. It's length in millimeters, the weight of the fish, the age of the fish, and the gender, whether it's male or female. Now, you'll probably notice that the location here, pane, isn't spelled consistently. This fourth operation or fourth line here has a lowercase p instead of uppercase, and we also see some inconsistencies in the uppercase lowercase values for gender. So we could obviously address those really quickly here since it's such a small data set, but we want to illustrate some tools in SAS that help us find those kinds of errors and then have SAS repair the errors. So in a data set that's as small as this, you're right, we could just type over things and fix it. Okay, but we'll keep our data set small here initially so we can see really kind of what SAS is doing. So we look at objective 1 and we decide then we'd like this weight measurement, this length measurement that's written here, instead of being in millimeters, that it were in inches. Well, calculator functions, and you could make that calculation if you wanted to by finding the conversion factor and physically going in and recalculating anything, but let's let SAS do that. So when I see this data input data lines, what I need to do then is, if I want to take any of these existing variables and look at a modification of them or a function of them, I can do that on a new line after input and before data lines. And the syntax of what I want to put in here is create a new variable following the SAS naming conventions outlined in Chapter 2. So we have new variable equals some algebraic function of the existing variables. And so for us, that is, I'm going to create a length underscore in for length in inches. That's going to be equal to length, which is the name of one of the previous variables, and I'm going to divide it by 25.4. This is the conversion factor to move from millimeters to centimeters. You might notice that the L up here is uppercase and this is lowercase, and that's okay. Remember that the case that we use in the input statement does establish how those variables will look in the output, but when I use them in other lines of programming after the input statement, it doesn't have an effect there. This new one, I also put it as a capital L first, and then I wanted to distinguish it from the one we had above, and so that's why the underscore inches, or IN. So that an underscore kind of visually gives us a feel sometimes that we've put a space there. Okay, so we could run this and what we would have to do is add a run statement here to this data step. And I'll add a quit statement also. So if we run or submit this, okay, there is no results viewer because remember the data step doesn't produce any printed output. We haven't requested any, and we can move to the log window. It says we have 6 observations and 7 variables. So what are those 7 variables? I have ID is our first, 2, 3, 4, 5, 6, and then we created a 7th here. So if we wanted to see the order of things, we can add to this. Then after our run statement here, we can look at a print procedure for the fish data set, and we can just add, well, let's see, we should probably put a title here for our objective 4.1, and then we can run this. So if I click submit, I'm going to get it's going to run again the whole program. I scroll up some more, you can see the first run where I just had the data step alone. I've got results viewer here. I don't notice any errors that occurred, and so in the results viewer I find that I do have 6 lines of data, and then how many columns? 1, 2, 3, 4, 5, 6, 7, plus the observation number that SAS puts in there whenever I look at a print procedure. And so the length in inches is the last variable created, so it is the last column in this table. If I wanted these variables to be printed in a different order, or I wanted these observation numbers suppressed, we could have done that in the program. We could have put the no obs observation, the no obs option on the proc print statement, and that would suppress those observation numbers. And if I wanted this length in inches to be printed next to the length, I could have established that using a variable statement. In here I could have included a VAR statement, and then for each of our responses, and suppose we want to keep length in the middle here, but we also want length in inches, and then weight, age, and gender. And then when we print this, it tells me I have an error in my length variable here. So let's come in and fix that. And notice it was a critical error because it didn't generate any output. I had no update in the results window, and it didn't automatically move me to the results viewer after it ran. So now if I try it, there we go. Now it did run. I can move to the log window. Remember, I just highlighted the print procedure code, and I got the results viewer here that I wanted, where I have the length in inches adjacent to each other in the data table. I left the observation numbers on, but we can use the VAR statement or not. Remember, the VAR statement for the print procedure not only reorders the variables that you want, but selects which variables you want. We could look at other transformations or creation of new variables, and again those would just be inserted after the input statement and before the data lines, and so we can stack up a number of these so long as we have it of the form new variable equals algebraic function of the existing variables. And what I haven't shown you yet then is what are the algebraic tools we can use. So the simple arithmetic operations then are addition, subtraction. We can use an asterisk for multiply. We saw the slash for division, which is fairly intuitive. Double asterisk is exponentiation, and then just parenthesis as needed for grouping symbols. You don't need or cannot use the square brackets and then those curvy looking braces that we also see in algebraic writings and things. Everything in the programming here, when you want grouping, you use parenthesis, and so it is permissible to nest parentheses as needed. Additionally, we can use other data step functions, and so this would come into the same syntax. New variable equals a function of existing variables, and so here some of these we can look at are mod, for those of you familiar with, say, mod 2 or mod 3 arithmetic, return the sign or a zero, a square root function, absolute value, greatest integer, etc. So you find all these in that list in table 4.2. Statistical functions we can use are it takes the mean of, well, now when it writes argument 1 comma and then the ellipsis here, you have to fill in all of these. So recently when I'm doing this, I had several variables in here, and so I had to write variable 1 comma variable 2 comma all the way to the last one, and that's for all of these statistical functions. So this is different. These statistical functions are different than what we saw in proc means. In these statistical functions, it's going to go line by line, and it's going to say for the mean, it's going to compute the mean of each of those variables observed values in that line. And that's not what the means procedure does, right? It works on the column of data. Trigonometric functions, and so for those of you with a background there's sine, cosine, tangent, etc. Text functions, we saw perhaps an opportunity to use that to correct our data. You can use an uppercase function that says converts everything to uppercase. Likewise, there's a lowercase function, or proper case, where the first word is uppercase and the rest of the word is in lowercase. There's miscellaneous things that I find helpful, and some of the programming I do is this underscore in underscore. It recovers the observation number. So remember, when we do a proc print, we see an observation number there. Appears like it may be a variable. What if it's important? So if you need to recover that number, suppose things are chronologically important, that observation number can help you recover that, and so you refer to that as underscore in underscore and set it equal to a name, because otherwise this underscore in underscore doesn't have a meaning outside of a data step. Also a lag function, so suppose you know the data are in a specific order and say I need to recover something that's 2 lines ahead. Well, I can lag 2 in a particular column and go back and recover something that occurred in an earlier line when the data are entered in a meaningful order. In Chapter 2, we looked at an example where we had a grade book or class of 6 students. And so let's look again kind of at that setting. We had these student names, we had their ID numbers. Now then there are 3 exams in the class. We have scores for the students for those 3 exams. We have 5 quizzes here also. We do have some blanks in here. Bill is missing quiz 4. Dana is missing exam 3. And so that if we want to create a SAS data set, then for this information we can use these column headers here as our variable names. And how do we handle missing data? Remember, we need to input a period for those missing values. Alright, so now then creating a data set called grades. I have the information then that occurred in that previous table. I have a missing value here for Q4 for Bill, and for exam 3 I have a period indicating a missing value for student Dana. Now then, once we've got this data set grades created, what we would like to do is compute the total of the 3 exam scores for each student, the number of exam scores for each student, the average of these exams for each student, minimum, and then also we would like to look at a quiz total. So when we do this, we have more than one way that's available for us to do this. So we look at these modifications that goes after the input statement and before data lines. Alright, so now then, whenever we want to compute the exam 1 total, exam total for all of those 3 scores, we can do that 2 different ways. So I can use that sum function. If you go back to those algebraic functions, I could use a sum function in here to do that. Alternatively, you said, well, there's only 3 items there, so it's not that much the problem here, that I can just add them up. Okay, I'm giving those 2 different names here, exam 1, exam total 1, and exam total 2, because I have to have different variable names, and so these ought to be in agreement if they're computing the exam scores. How would we look at the number of exams? Well, on the previous table of algebraic functions, we had an n function which defines the number of exams completed, and so that we could look at that as exams capital N here. So I've got here a remark off to the side. Notice it's in a different color, so whenever I see an asterisk followed by text and punctuated with a semicolon, that indicates a single line comment, and we'll start to introduce those from time to time. The details on those occurs in chapter 20 on our miscellaneous topics, where you find information about inserting a comment in your program. So it's always a good idea to annotate the programs. So if I'm looking at this number of exams, and so if someone says, I don't know what this n function means, they realize it's a function operating on 3 exam scores. It's the number of exams that are completed. Likewise, we need to look at the average of the exams, and so you may also look at that and say, well, I can do that by using that one of the functions again, and so we had a mean function which takes the mean of these. So notice I did fill in the exam 2. I can't put in an ellipsis here. That's not going to work. Okay. Alternatively, because they're small enough here, you might think then that we could just add them up and divide by the number of exams. Well, if I'm computing the number of exams, because I already know one student is missing an exam, we want to see how that's handled. And so I can put this function, this new variable that I've just created, inside this function. So here, new variable equals these the sum computed as an arithmetic function divided by the number of exams. Now the thing you'd have to watch out for is that this exam average 2 cannot occur above exams n, because exams n is used in this line. So it has to be created previously in order to be used in this new function. The other thing that we needed to do here is we wanted actually 2 things. We need the minimum quiz score. Maybe we're interested in dropping the minimum, and so how do we recover what that minimum score is? And then we also have the total of the 4 best quizzes. So our best 4 quiz total, well, I could add all the quizzes up and subtract that minimum quiz that I just computed, so that way I get the sum associated with the best 4. So this sum right here, I could have replaced with the arithmetic function q1 plus q2 plus q3, so I don't have the other option here. For minimum quiz, I don't have another function I can use. Now what I could have put in here, instead of min quiz and repeat this function, I could have put in this new min quiz variable right here because it was created previously. Either one of those approaches works. So now then, once I have this, then I want to examine all of these things, and so let's say I just want to print the exam information together, and then I want to print the quiz only information together. I can do that. Okay, I create a table where I have just exam information. I have the student name. I don't need to repeat the ID here specifically, and I want the observed 3 exams, and I want to compare this exam 1 to the exam total 1 and exam total 2 number of exams, and also these two different ways of computing the exam averages. And then I have the quiz information together in one print procedure. So let's go ahead and submit this program. Notice I have two print procedures for Objective 4.2, which is what I requested. So in the first one, for the exam 1 or the exam only information, I have the 3 exam scores for each student printed here, with the exception of this missing value here. So exam 1 total, it totaled everything up. So if all 3 scores were present, both of these match, exam total 1 and exam total 2. For exam total 2, there's a missing value here, but there's not for exam total 1. So what happened? Okay, so let's scroll back up. Exam total 1 is a function. Exam total 2 is an arithmetic operation. So whenever exam 3 was missing, what that caused was the arithmetic operation to fail. The sum, it took the sum of those that were not missing. That's important information to know. Alright, so that when I look at these exam totals and I see this, and versus this one, so if this individual hasn't taken the test, maybe due to illness, then I know this one indicates that it's missing, and so there's a problem that exists. When I look at this one and I see it's completed, that this value is computed, and it's much lower than everyone else because of that missing value, I need to go and investigate why that is, or if it's missing and should be regarded as a 0. So there's two different things going on here. So which one is appropriate for your interpretation? Likewise, if I can look at the number of exams, and so clearly here for only 3 exams, and there's only 6 lines of data by visual inspection, we can see this. But imagine you have very large groups and you're trying to measure how many observations exist, or how many columns of data exist for each ID, and so then this exams in, or that gives you a count, becomes quite helpful. The other things we have are 2 different ways of computing the exam average. So notice the mean function works when you have missing data, but the arithmetic function for the exam average did not, again for the same reason. So when it's an arithmetic function, a missing value will generate a missing value for those computations, but whenever you have a function, an algebraic function, missing data are not going to cause a problem with regard to output. Is it meaningful output is the decision you have to make in your application. We also wanted to look at the quiz, the best 4 quiz scores, and so notice Bill has quiz 4 missing here. So what's the minimum quiz score going to be? So it's 16 here, not the missing value. That's important to know, okay? Because if a missing quiz score should be interpreted as a 0, clearly here it is not. So we want to know that we're adjusting for missing values the right way. Again, so both of these were just examples were created to illustrate when the effect of missing values on any of your data manipulations. And then also we revisited the print procedure with the no obs option in both of these. Now, if we revisit the fish data that we saw in Objective 4.1, and as I spoke then, we noticed that we had some issues with lowercase p and uppercase f in a couple of places here in lowercase f. So the only place we've seen where SAS is case sensitive so far is in the input statement, that whatever case we specify here is how things are going to look in the results viewer. Likewise, anything in quotation marks, that's really not SAS code. That's whatever text I choose to put in there, and so therefore that's my text, and it is case sensitive. This particular data set is going to illustrate also that data are case sensitive. And so this is how that works. So if we look at objective 4.3, it says to sort the data by gender and print the data by gender. All right, sort by gender, print by gender. Okay, so let's add this on to the previous program. So we proc sort data equals fish by gender. We want to print it by gender, so all the males together, all the females together. Print, we're not doing anything mathematically rigorous here, just looking at brief reports by gender. So again, in practice, our data sets would be many lines longer. I guess I only need one quit line in here. And so that I can, now here I'm going to demonstrate something that the video allows me to do that the book doesn't always let me do as easily. And so this data set fish exists in SAS memory until I close this SAS session. So therefore I can look at this, and as long as I've not overwritten the fish data set, I can pick up code that says use data equals fish, even though I've ran this data grade set of this grades data set here. So I have two active data sets, one for grades, one for fish. So if I look at this one and I can just pick up this code and submit it, it's going to still generate printed output. So notice I have a new print here, objective 4.3. I've not done any clearing either through display manager commands or moving to the results viewer or log windows to clear those. So I have an accumulation of results here in this results pane on the left side of the screen. Objective 4.3, I expected that I would have a table of observations for females given by F and a table of observations for males given by M. Notice here I have gender equals capital F and gender equals lowercase f, and then gender equals lowercase m. So I do have all 6 observations here sorted, but it regards uppercase as something different from lowercase. That is because the values capital F and lowercase f are data. Okay, data are case sensitive. So that I would like to be able to fix that, because these two tables for females should be combined together. So how can I do that? Well, again, when we have a small data set, just going back up here and typing over will fix it. But imagine instead of 6 lines of data, you have 600 lines of data. Then you become more motivated to learn how to use commands to correct those errors. So we can either make these genders either all uppercase or all lowercase, doesn't matter. We just need to pick one of those. So if I choose to make them all lowercase. Okay, so 2 things going on here is first the application of the lowercase function on the variable gender. So all of the things in that gender column will be converted to lowercase. Now the new part here is that notice that the variable over here to the left of the equal sign is the same as the one in the function. So you can overwrite the original variable doing this. So you can say same variable name equals lowercase same variable. That's going to overwrite it. In the line above where I had length, remember I said length in inches and the original length variable. So when the existing variable is always on the right side of the equal sign, new variable on the left. So in this case I'm keeping the old variable and introducing a new variable. In this second case I am just changing the value of gender and replacing it or putting it back in the same place. Okay, so the very different approaches here. So you want to make sure that whenever you overwrite the original, that's an okay thing to do. If I wanted to keep what the original data entered for gender was, then I could call this something else, gender 2, gender N, or whichever gender low, however you wanted to do that. Okay, so in this case it's just going to overwrite it. Now I can't just come down here and grab this procedure and run it. Then the reason I can't do that is because the dataset fish hasn't been changed yet. So you could do this a couple of different ways. You could either rerun things, the whole program, top to bottom on submit. You'll get objective 4.1 again, objective 4.3 again. Okay, or you can pick up the dataset in a run statement and submit it. Okay, let's have a check, make sure that worked. Okay, so it says it didn't have any errors there, so we'll move back to the program, and then we can run just the objective 4.3 again. Okay, objective 4.3, so now all of my female gender are indicated by lowercase f, and they're all in the same table, and gender M, all these are in the same table. Okay, so that corrected that data entry problem. So this idea of having this can come about if you have multiple people entering data. Some of them may have a caps lock on and some may not. Similarly, we could have used the upcase function or the propcase function and made the changes to gender with either of those two. So, and they would follow similarly to this illustration here using the lowercase function. Okay, when we reran this last one with 4.3, that was the corrected version of objective 4.3. In the book it's marked objective 4.4. If we move on to objective 4.5, the word Payne here is Payne County here in Oklahoma, and so this value lowercase p seems to be an error when this is a proper name, and so that I want to fix that, and so I can use the proper case. I also perhaps am working with individuals at fisheries in other states, and so it becomes important not only just to put the county information for the location in my data set, but if I'm going to communicate to that, we want to make sure and add Oklahoma or the abbreviation for Oklahoma, which is the uppercase OK, to every line of data. Well, I could create a new one in here and put in a state as well as a character variable and enter it, or I can use a variable assignment statement to do that. So we want to be able to add the state of Oklahoma and correct Payne County. So to correct Payne County, we can use the proper case function, or prop case is how it looks, and then create a new variable state. So here in this line we've created a new variable state. I've made it uppercase STAT. When I initialize a variable, it's case sensitive in that initialization, and it's equal to text. And when we use something that's equal to text, the text we can enclose in quotation marks. It can either be double quotes or single quotes. So this says for every line, state is equal to OK. The location was the county information within the state of Oklahoma, and I just need to make those proper case, and so that if I want to combine things from another county within Oklahoma, I need to make sure that I have the location spelled correctly. If I want to combine information with fisheries from other states, I need to have the state information in there also. So here then in this data set we need resubmit the data set so we can expand on what this data set looks like. And then we can print it to observe the effects then of these new changes. So instead of our quit statement here, okay, we're going to print this, and I'm going to put location and state, and the length in inches, the weight, and gender. Okay, and so then since I have resubmitted the data step fish, that means I can go through and submit this code and it will do the right thing here. So previously I had an observation here with Payne misspelled or as lowercase. Now those are all fixed. I've inserted state equals Oklahoma, and the reason state occurs as the second variable is because I placed it second in the VAR statement. Without this statement in here at all, if I would have taken that out and run this, You'll see we have 4.5 twice now. Okay, this is the order in which the variables were created. I do have the corrections in there for gender and the corrections in there for location. State was the last variable created, and it is the last column then in the data set if I don't use that VAR statement. So if I use the VAR statement, I control which variables and the order they occur. We'll pause here in Chapter 4. We have much more to do in Chapter 4, and we'll do that in a second video.